right, so we're going to try this again. So this will be my second attempt at trying to stream. And it's okay because this is part of the learning process for me. And so I am very familiar with having things like this happen. And so just roll with it. Technology is not always going to cooperate. So we just have to develop a attitude that we're never going to give up, no matter how hard it gets. Okay, so as I was saying before, since the technology is working right now, what I'm doing is I'm taking the derivative of this function and I'm going to calculate it. And then after I calculate the derivative, what that first derivative is going to tell me when I solve for x is those are going to be my critical values. That those are potential maximum, minimum inflection points. And then, so we're going to calculate that first derivative and solve it for x. We're going to set it equal to 0. And find values in the graph that that first derivative is 0. And by doing that, what we're doing essentially is finding critical values for our function, for the graph, the pictorial representation of it, essentially. So, all right. So we're going to start by using the power rule. And again, what the power rule is doing is you're taking the exponent, multiplying it. So it's going to be 2. We'll do this for the first term and then I'll just kind of go faster. So it's going to be 2 times 4. And then you're going to have your variable. And then what you're doing is you're going to subtract the exponent. So you'll take it down a degree. And so then that would equal, and we'll go ahead and put it in here and then I'll erase. 2 times 4 is 8. And then 4 minus 1 is 3. So that becomes this term, when derived, when you take the first derivative of it using the power rule, you get 8x cubed. All right, so let's see how fast we can do this. So this is going to be 2 times 4 is 8. X, 4 minus 1 is 3. And then 17 times 3. What is 17? 60. 57. Was it 57? 17 times 3. Yeah, 51. I was off. That one. Okay. So minus 51 x squared. Okay. And then 46 times 2, that's 92. So that's plus 92x. And then 43 times 1 is just 43. And the x term is going to drop off, and then that constant term is going to drop off. So because this is your linear term here, it's just shifting it over one a little bit. All right, so this is the first derivative, okay, and this is going to help us now. How is this going to help? 43, let's see. See, 43 does not divide 8 evenly. And 43 is prime, I think. Hang on. 43. No. No. Yeah, I think 43 might be prime. Okay, so then that's going to be the intercept. Let me see. 8x. This is going to be a booger. All right, so I'm going to have to plug this function in to my calculator to see if I can, because there's rational zero, there's not any rational zeros. Let's see if there's another way to solve this. That's why technology is your friend sometimes, but let me just see what the graph. 8x cubed. And again, reminder, I am just hanging out on my board, and I know that I'm not really doing a whole lot to advertise, and so I'm going to try to get back into that a little bit more. But if there is anyone out there hanging out and you do have a problem with your math, I can stop working mine at any point in time to help you. And I'm willing to do that because that's really why I'm here. Offering my board and my time is to try to help young people. So, like people that are, you know, just starting out. Maybe you like math, maybe you don't like math. All right, so we've got 8x cubed minus 51x squared plus 92x minus 43. Let's see. So what I did was I just put it in the graphing calculator, and I'm going to calculate the zeros. So you go into the second calculate function and it will calculate your zeros for you. So I'm just going to see if I can get one. Otherwise, how would I be able to solve this if they don't have clean zeros? Because they're not. So left bound. Hang on, let me just see. Okay, so it's saying 0.72. Can we do math 1? Let me see the table. Okay, second. Well, it's saying that, so it's going to intersect, well, I know that it intersects y at 43. Let me see. I'm just trying to figure out how I could solve this. All right, so I don't know how to solve this. So I'm going to have to think about it. So that's okay. That's good. And I heard this one time somewhere, and I really liked it. So it's not mine original, but mistakes just means when you make a mistake, that just means that you try to do something that you didn't, new or hard or challenging. Mistakes are good; they're not bad. All right. So what I'm going to do is I'm going to go ahead and I am going to calculate f double prime of x. Okay. Let's go ahead and calculate that second derivative, because while the first derivative is going to tell me possible values to check, that second derivative is going to actually tell me where the party is at. Okay. Like specifically, it should tell me the specific critical values. And right now I'm suspecting that there are 3 of them. Actually, I looked at the graph and there's 3 clean intersections on that first derivative. However, they're not clean factorable. And honestly, I was remembering some of the calculus that over the years, and there's a way to use the circular coordinate system to calculate real roots. So if the roots are not clean, they're not pretty, and they're not factorable, then the quadratic formula is only good for a square function. So since I have this cubic issue, I have to find alternate methods of solving it. So I'm going to have to go back and relearn how to use the circular coordinate system to solve for these the actual values of these other higher order polynomials that you wouldn't necessarily be able to. So there is a way to do it. I'm not there right now. So we're going to go ahead and calculate the second derivative, set it equal to 0, and solve it for x, and then that should tell us the exact critical values that we need. So we're going to go ahead and do that now. So you recall the method. You are going to calculate f prime by taking f prime and applying that same rule, the power rule. And I'm going to do that to each one of these terms. And I'm going to do that to each one of these terms individually, separately. So 8 times 3 is 24. And that's x squared. 24x, that is a very big coefficient. And then we have 51 times 2. So that is 102. 102x. And 92 times x to the first. So that's just plus 92. And then this 0 term, it's 0 minus 1. This is going to drop off because it's 43 times 0. Okay. So here is f double prime. And this is much more comfortable territory. I am completely 100% solid on solving second degree polynomials. Like, those are elementary to me at this point. All right. And right now I'm trying to remember, because there's also a way that you can use substitution. So I'm trying to figure that one out too at one point. So, and one of the things that I'm realizing through this project that I'm doing is how much I've forgotten. So hopefully I remember it. All right. So what we're doing is I don't think does 24 go into 92? Let me see. I don't think it does. No. Yeah, you'd be able to reduce it down a little bit, but what we should do probably is go ahead, we can divide all of the even numbers out. So 24 divided, everything can get divided by 2. Start there, divide it by 2. Or what we could do is we could just solve it for the quadratic formula. Maybe we'll just practice the quadratic real quick. All right, and we'll see how it goes with bigger numbers. I do want to get back to quadratics after we look at these higher order polynomials so we have the quadratic formula. I'm just going to put x equals, well, I need to go ahead and put the variables. I'll list them just in case. All right. So we got a equals 24. Yeah, I think I'll get better from this angle. B equals negative 102. And C is going to equal 92. So we'll just see how it goes. And we have x equals, so we'll have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, let's see what we got. So that's positive 102 minus the square root and then 102 squared. When you square a negative, you're going to get a positive. And then I just have to figure out what 102 squared is. That is 10,404. 10,404. All right. And so then we got 4 times 24 times 92. That's 8,832. Okay. And then we've got 2 times 24. Well, 2 times 24, that's 48. All right, so we have x equals 102 plus or minus the square root of 10,404 minus 8,832. And I'm getting 1,572. 1,572. And that is all over 48. And I know that you can't see what I'm writing because I'm a lefty, but I'm working on that. All right, so we have x equals, so we've got 102 plus or minus. What is the square root of 1572? All right, we're going to have to go off on a little tangent here and reduce this down because I want to keep it in radical form for my graph. I don't want to get a decimal approximation. I mean, I will just so I know where to put the point, but I want to always stay in exact terms. So we want to keep the fractions. Remember, fractions, I wasn't joking when I said fractions are your friend. They really are, because they're exact values. They're not approximations. When you have a fraction, you have an exact value. And that's the beauty of it. Okay. All right. So 102 plus or minus, I have to break down this 1572 and this, the lost art of reducing radicals and simplifying radicals. And so this is a big deal. I'm going to go ahead and do it right down here. Let's see if I can. Okay, so the square root of 1572. So we're going to take 1572 and we're going to split it up to its prime factorization. Okay, we're going to find it's all its prime factors. And if it's even, I just start away. If it's divisible by 2, I will start by dividing it by 2. So that's 782 times 2. If it's divisible by 5, I will just start by dividing it by 5 and vice versa through all those first primes. So, wait, 786, sorry, 786. And let's see if that's divisible. I know it's divisible by 2, but let's see if it's divisible by 3. Yeah, it is. Okay, so we've got 262 times 3 times 2. Okay, and then that's divisible by 2. So divided by 2 again, and that's 131. Let me see. So 131 times 2 times 3 times 2. Okay, and then 131 divided by 3, nope. 131 divided by 7, no. So 131 might be prime. Maybe I should turn this other monitor on and ask Google. Let me see. If 131 is prime, because I think, let me see if I want to check a couple more. 13. Okay, so whenever you get a prime number, then you stop. Okay, it says it is, and I figured it was. All right, so here's your prime factorization. And so you're just putting all of that under the radical. So you've got 131 times 2 times 2 times 3. And so since 3, so you're just pulling out perfect roots. So I can factor 2 out. That's the only one. So 131 times 3. You just multiply those back together. 393. So it's going to be 102 plus or minus 2 radical 393 over 48. And I don't think that 48 is going to divide 102 evenly. So you'll just end up with really ugly numbers. It's okay. So we have two values. We have 102 plus 2 radical 3, but more importantly, these 2 points right here. We can simplify a little bit. We can just pull a 2 out. All right. Are telling us that these are the places in the graph of my my minimum values here. And I need to go ahead and probably check to see if this, I can plug this function in my graphing calculator and open the table, and it'll tell me if that's I can look at it that way and see if that's my maximum, but I'm gonna go ahead and suspect that 2 is good solid, and we'll change the curve a little bit. Let's see. Probably more softer like that. And then I'm suspecting that these two points right here are probably in here somewhere. So let's go ahead and figure out the decimal approximation just so we know where to put them. And then we're going to plug them, more importantly, we're going to plug these 2 points into the function and see where y is at. Okay, so -1, -2. All right, so let's do it. So 102 divided by 2. We're just going to pull a 2 out of everything, make it a little bit easier. That's 51 plus or minus radical 393 divided by 48 divided by 2 is 24. Okay. So I have to figure out what. So we've got 51 plus radical 393 divided by 24, and we have 51 plus the square root of 393. Second answer. divided by 24. Okay, that's saying 2.95. So 2.9, so almost at 3. So we're almost at 3 here. It's saying 2.95. And then the other one, we'll say minus, is 1.29. So 1.29 is in here somewhere. So we're in here, and then we're going to be in here. Unless I made a mistake somewhere. All right, so let's go ahead and look at the graph of it. So I've got that one. Let's go ahead and put that original function in. I never did. All right, x to the 4th minus 17x cubed plus 46x squared minus 43x plus 12. Okay, well, that's 2, wait. Okay, see if that helped. I put something in wrong. So this is helping me realize how dependent I am on the technology. Okay, it's still showing the graph existing in the negative. So, okay, well, anyway. This did not help me because I'm in here. It's saying there's a critical value, but these are my zeros. So let's go ahead and plug in the function, something here. So I know that we've found these other values on the graph. So I'll tell you what, we'll go ahead and give it the benefit of the doubt, and we will plug this number into I think we can go ahead and just plug it into the original, not the original, but double prime. So we'll plug it back into double prime and see what it does, see what happens. Okay. Wait a second, it's going to tell me it's 0. Because I set it equal to 0, those are the zeros. I'm going to put it back into the original function. So I have it stored in for x. So I can quit. All right, let me go ahead and store this in for x. All right, so I have I have the positive value stored in for x, and so I type the function in. 2x to the 4th 16x cubed plus 46 x squared minus 43 x plus 12. And part of the tragedy is that it's saying 219. Part of the tragedy of the whole thing is um, you could be doing everything correct and just enter something, make one minor mistake. And it's, that's one of the reasons why, people develop uh, hard feelings toward the subject, but you just have to keep going. All right, so you just have to find a workaround. It's saying at this first value here that we're at 219. So this is probably not giving me my minimums. What it's doing is it's giving me my inflection points, I think, because it's saying it's at 219, just over 2, and that's going to be this value right here. And it's about the middle. Inflection points are kind of a more of advanced topic, but it's where that graph is shifting from its in its concavity. So like this one, if you were describing the function from, you always start from left to right when you're describing a function. You start with negative infinity and you move to positive infinity. And what you're saying that, okay, so along this interval where it's existing, the graph, it is decreasing in nature. And then it gets to a point where, and this would be, the derivative would be 0 here. And then what happens is it shifts in concavity and it starts increasing at this point. So it's increasing on this interval up to this point, whatever the maximum, and then it's decreasing again. But see, it's changing concavity because it's concave up here, and then it's concave down, and then it's concave up again. So the inflection points are specifically where the function is changing from being concave up and an increasing function to concave down and being a decreasing function, if that makes any sense. Anyway, all right, well, we're just having fun, hanging out all night, doing some math, and that's the point of it. And so it's not to be perfect or even necessarily sometimes you're not successful, but I think that if I work hard enough, that eventually I will be successful. So, and never give up. So we did have some technology issues in the beginning, but we made it through, and it's almost 7 o'clock. So I want to kind of keep it between 6 and 7 strict at first, especially since I don't have like anybody watching or a whole lot of viewership right now. It's fine. I just will be thankful for the opportunity and treat it like it's a win and a growing opportunity for me. I will be back next week, Monday through Friday, from 6 p.m. to 7 p.m. Central Time. And thank you so much for watching my videos, and I will see you next time. Bye.